Good morning, everyone, and welcome to another Fusion Friday. My name is Alex Alvarez.
My name is Brian McMaster-Carr.
And we're application engineers here at KETIV Technologies. So happy Friday, everyone. Thank you for tuning in to another Fusion Friday, like I mentioned. If you are new to Fusion Fridays, just a quick overview on what they are. So it's a series of webinars, right, where we go over all the workspaces that Fusion 360 has to offer, as well as some of the updates and tips and tricks that we've learned here along the way. So for today, Brian is going to be talking about 3D printing threads with Fusion 360, right? So that's common. We've seen that additive manufacturing has really started to pick up. Maybe a lot of people are using it for prototypes as well, right? So threads are pretty big here in the 3D printing environment. So hopefully Brian can show you or shed some light on some tips and tricks and hopefully show you something brand new, right? Yeah. So with that, I'll go ahead and pass it over to Brian and get it going.
Cool. Thanks, Alex. So before we get started, if you guys have any questions at all, feel free to ask them at any time in the go-to webinar chat. And if you miss any of this webinar, we have a YouTube channel. So you can always, we're going to upload it in about a week or so, and you can always reference this video later down the line. All right, so let's go ahead and go on to this next page here first. So I like to start off with the purpose of why we do these webinars. And today's purpose is because technology is rapidly increasing now more than ever. If you're not at the forefront of it, then you're going to fall behind. And 3D printing is going to be one of that technology that we all know is the future, whether it be medical or just printing them for prototyping. It's very cheap and fast form of manufacturing. Also, think of this as a time saver. All the hours that Alex and I spend on 3D modeling in Fusion as well as 3D printing, we all cram it into this 30-minute training session for you guys. So just think of it as instead of spending all those hours and learning them for yourselves, you can just learn it here within the next 30 minutes. Also, if you don't plan on 3D printing, but you just want this for your own for your own reference, it's good to have this kind of knowledge for you to make those smarter decisions later down the line. And if you are using this for 3D printing, then perfect. Then ask those questions because I'm sure you'll have a lot of it, because this is completely new kind of webinar that we're doing for this, or a new topic that we're doing for this webinar here. And next are the goals. So the goals for today is to do one of the easy ones, which is importing a McMaster-Carr component. Another one would be to show you different techniques to modeling threads in Fusion, whether it be custom threads or whether you want to adjust the tolerancing of the size of the thread so it can fit better. I don't know if you guys have 3D printed before, but there's always initially that issue. And also best practices for 3D printing threads. A lot of people haven't had too much experiences with 3D printers, or they're too afraid to do anything with the 3D printer yet. This is going to help us through that. So once again, this is a reminder to ask those questions in the chat room, or we're going to share our phone number and email address, or the company's phone number and email address at the end of the webinar. So feel free to email us personally as well if you have those individual questions. All right. So let's get into Fusion 360 here. I have 3 different examples for you guys. The first one is going to be this toilet paper holder. It consists of these 2 brackets here and the back plate to hold the whole system together. But what we're missing are the bolts that go through these holes here. And notice how this hole is actually a 0.2875 inch diameter, but we actually want to put in a 3/8 bolt into that. So do we need to change the size of the hole? Actually, we don't, because with the thread tool, it actually adjusts the size of a hole for us. And I'll show you what I mean by that in a minute here. But first, let's go ahead and bring in the bolt that we want to insert. So speaking of insert, we'll go to the insert command, and we'll insert that McMaster-Carr component. And if you guys don't know what McMaster-Carr is, it is a very popular website that stores all these different hardware in it, whether it be nuts and bolts, whether it be hand tools, hardware, or just everything you need can be found here at McMaster-Carr. So I'm going to go ahead and grab socket head screw. And I'm going to choose an alloy steel that's fully threaded. And I'm going to go here to the left-hand side and start finding my bolt through here. And I said it was going to be a 3/8 inch size with 16 threads. I'll choose the 16 thread one. I didn't mention that earlier, the 16 threads. And we'll make it 1 inch in length. And lastly, I want a black oxide finish. And now it narrowed it down to this one item here. So if you guys have been in here before, you pull your CAD model by hitting product detail from here. But not all items in McMaster-Carr have that CAD model linked with it. Some of them don't have it just because they haven't designed it yet. But most of them do, especially the nuts and bolts. So to get to it, first, to find out whether it does or doesn't have that CAD model, it says CAD right here in the green. And then to get to it, you hit product detail, and that gives you more details regarding this item. And then we're going to save this. For some reason, the SolidWorks format doesn't come in via McMaster-Carr, but we do. We can import that in the regular Fusion workspace. But in this case, we're just going to change it to the 3D step instead, and then hit save to import it that way. And this tool is cool because it skips a few steps for us. It saves it directly into Fusion, and we didn't have to go to the McMaster-Carr website. 2, we didn't have to save it locally from McMaster, and 3, we didn't have to import it into the software. It eliminated all of those 3 steps for us. So now we have it here ready to be inserted into our pocket there. I'll orient that to the vertical position. And now, just for those of you who use SolidWorks, just like the make command, we'll use the joint command. And we're going to place that into our model here. And I'm going to leave it as a revolute type motion. I'll show you guys why in just a second. But yeah, so I'm going to leave that as revolute, and we'll be good to go there. So now that I have it in my bracket, I'm actually going to hide it for now. We're going to come back to it in just a bit. But what I'm going to do is I'm going to create the threads in this hole. And to do that, we have the straight out of the box tool, which is the thread tool, which can also be found under create here. But I pinned it to my toolbar just for quicker access. And for the thread tool, all you need is a cylindrical face to use it. So I'm going to select this cylindrical face there. And to select the other cylindrical face of the back plate, I'm going to hold Control. It's highlighting, and then select that one as well, and then release Control. So now I have those 2 selected. But notice how this is actually just a picture representation of the thread, and it's not actually modeled in threads. So if you want it modeled in, simply check the model box, and it models it in for you. But I would be cautious if you aren't actually 3D printing these threads and you leave them as modeled, and you have, let's say, 100 different threads in your design. It might slow down your file because it takes more CAD data to have these modeled in like that. So if you're not planning on 3D printing them, I would suggest you leave them unmodeled so it'll run just a little bit faster for you. I'll leave this box checked for the full length of the thread. And then the thread type is going to be the ANSI unified screw threads. You can also do a metric as well. And like I said, we want a 3/8 size hole. Notice how if I choose a 1/4 inch, it shrinks the hole for us. So it doesn't matter what size that cylindrical face is, like I mentioned earlier. But for 3/8 inch, that would be a 0.375 inch hole. And the designation it gives us the 3/8 and the number of threads we want. The one we chose in McMaster-Carr was also 16 threads, so we'll leave it at that. And the different classes. So if you want a looser fitting thread, you choose something like 1B. If you want something that about 90% of the community uses, that'll be a 2B class thread. And if you want a more tighter fit, if the thread tolerancing is really critical for for your field, then I would choose a 3B. So we'll just go ahead and choose a 2B. We can choose the left or right hand direction. And if we check this box right here, it will remember the settings that we chose for this thread. So all the thread type, the size, designation, just by checking that there. So we'll go ahead and leave this as modeled since we're going to 3D print them, and go ahead and hit OK and see what happens. So it didn't model the thread for us, and it gave us this X error at the bottom right-hand corner of the screen because it failed to cut the thread tool body. This was a little bug that I found in Fusion, that if you try to do that thread via just going straight to the model, when you try to go across two different components like this, it gives us that error. So what you're going to want to do first, let me bring these guys back to the original settings there. What you're going to want to do first is leave the model unchecked. So we just have the picture representation. Go back into the edit feature and then hit the model. And now if I hit OK, it should leave that model in for us. So that's just a little bug that I found. Hopefully this will help you guys go around that bug if you try to model, or if you get that same error message that I did there. All right. So now we have our threaded hole. We have the bolt that goes in the hole. Let's check how this lines up. So what I'm going to do is turn on my analysis that I had previously, and we can view what this looks like from the side here. And notice how it's actually overlapping with the thread. And that's not because it was a different size. Rather, it's because the way I jointed or mated this into the part. And what we need to do now is actually rotate it. If we rotate the bolt or a screw correctly, it will line up with the thread on the bottom. So I'm going to right click. I'm going to use move copy. I'm going to select the body that I want to rotate. Then I'm going to select it's on the rotate move type. I'm going to select the axis in which I want to rotate it about. So I'm going to select the cylindrical face here. And then I can either manually rotate it, or I know the value that it's supposed to be rotated to, which is 270 degrees. So usually a clean value like that. If you brought it in just straight from McMaster, and now it's lined up the way we want it to. Now I actually printed this set after cutting away the rest of the model because I didn't need to print the whole model just to see if this thread worked. I printed the set and it came out too tight for me. Like it wasn't when I screwed it in, it was really rough to screw in, and that's because if you notice, the faces here are completely touching each other, and that was the reason why it was a little rough to screw in. So what I did next was I went into the thread and I gave it some breathing space. I used the press pull command, and if you guys remember from previous Fusion Fridays, this command allows you to directly edit the model. And let's see, I believe it's that face there. I brought it back about 5/1000ths of an inch. So I select this particular face. There's about 3 or 4 different faces you can choose from in this thread. And I pulled that back 5/1000ths of an inch. Now, if we show the bolt and the analysis again, you can see that it gave us that breathing room, very similar to the rest of the tolerances there. So then when I printed this, it screwed in just fine. So that's kind of what we're looking for here, is just any of these misalignments. So if you guys bring in your own bolts, try to do a section analysis to see if it's lined up, just to make sure it's going to fit, and 2, make sure there's some breathing room between your female and male threading to make sure that it's going to fit nicely. All right. So that's going to be the first example. Once you're done with the creation of this, you can export this out to your 3D printer. And if you haven't used it before, it's located here, 3D print. This converts it into an STL file. You can choose. I can choose one of these models here. I'll choose that one. And down below here it says output. It's going to send it to my flash print preprocessor. If you have another preprocessor, you can browse through here and choose your own. Like here's a MakerBot print, for example. And then when you hit OK, it's going to import it into the MakerBot print, or it's supposed to, but we'll see what happens here. So this is a slicer. There's a lot of different slicers that come with your 3D printer, and they're usually free. There's also ones like Kira that are out there that you can use. And notice how it doesn't actually bring in the model here. You don't see anything here. It just opens up MakerBot print. And the workaround I found for this, this doesn't work for my MakerBot print, but it does work for the FlashForge Finder or the Flash print. So if we chose the Flash print, it would have brought the model straight into it. But just for this slicer in particular, it brought us into that empty workspace. So instead, what we can do is save this as an STL file. And you could do that by going down here or going to the component here in the browser, right-click on it, and save as STL. And this allows you to save it locally to a location in your computer. So I'll just save it to my desktop for now. And then when you go to your, then when you go back to your workspace here in the slicer, you can insert that file. And then it'll come in. Obviously, this is too large of a scale there, but I would shrink this down to, it probably read it as maybe millimeter or inches, while maybe I was in millimeters or something like that. But you would bring it in like that, and then you can start 3D printing. All right, and we'll talk more about this later, but this is the method, a workaround method for bringing in an STL file. All right. Also, people wonder like how come it's not in the or why is it located here? People would ask me, oh, can you export as STL? Because they would normally go through the export tool here, and yeah, you wouldn't find the STL file type here, and that's why it's hidden in this component here. You would right-click and save as STL there. All right. So yeah, let's go to the next example here. So let's say you get a file from a customer, or you have this threaded bolt or screw that you want to create maybe the female component for. But obviously we do know the thread type here, but in case, let's say this was a different kind of thread and you wanted to create the female component for it, how would you go about doing that? And I want to show you guys this other cool tool that I use here in Fusion for that. So first, let's create that kind of base or that female component for it. So I'm going to create a cylindrical body. I'm going to go ahead and project the bottom of that there. And we'll just create a new body. And now we have two different bodies. I know some of you guys are thinking, hey, why don't you just create another component? I just want to show you guys the different, I just want to get straight to the point rather than worry about those components right now. So right now we have bodies 3 and 7. The body 3 is the original screw, and then body 7 is just simply a extruded circle. So what I'm going to do now is I'm going to use body 3 as a cutting tool to body 7. And to do that, we're going to use the combine tool here under modify. We're going to choose the target body we want to cut, and then the tool body that we want to use to cut with. And we want to leave it as a cut operation, and we're going to keep the tool body. Hit OK, and then we have a threaded a threaded female component to this body 3 here. And if we do an analysis, a section analysis of this, you can tell that these are actually flat on each other's face because of the method we used. And what we're going to want to do is, just like we did in the first example, is directly edit the threading to give it some more breathing room or tolerance. So first, I want to see an example of that side by side. So what I want to do is I'm going to select these bodies and then copy and paste it, Control-C, Control-V, and have one next to it like that. Then I'm going to delete these threads on the inside so that I can create my own threads. That I can use as a reference. So now body 8 and 9 over here on the right-hand side, if we do an analysis of it, has the tolerancing spacing that I want. The one on the left-hand side, we need to try to get to the one on the right-hand side. So to do that, let's go ahead and do the direct edit modeling again. But first, we need to see what value we want to create these tolerances as. So right now, it's in a section analysis. It might be a little bit difficult to measure from this distance to that distance, or from this point to that point. So there's a lot of different workarounds we have for this. The one I like to use is I like to just cut the model right in half. I'm using this rectangle and extrude cut command. So now we can measure this. So from this edge to that edge is about 4/1000ths of an inch. Then from this edge to that edge, 11/1000ths of an inch. So let's go ahead and apply that to this one over here. I'm going to go down to my design history, drag the design back to before that cut, and now I can edit this model. Directly grab this one. It was 4/1000ths. I like to think of in terms of 5/1000ths and 10/1000ths, so I'm gonna cheat a little bit and use 5/1000ths instead of 4/1000ths. And then I'm going to grab these 3 faces here and do the 10/1000ths instead of 11/1000ths. So they're close enough. It didn't work for the 3D print. All right. So now if we pull this back to the in the design history, it does that cut again. And now we can see that it looks almost identical to the thread, the out of the box thread tool. But we had our own thread created here using the combined cut method. And if we measure it, this should give us the 5/1000ths. And then this one should give us the 10/1000ths. All right. So that's the second method into creating threads, is to use the combined cut tool in Fusion. Last one I want to show you guys is to create custom threads. So if you have a particular shape of a thread at home, you can use this method here. First, let's go ahead and create a cylinder to create a thread on. And then we're going to use what is called the coil tool, if you guys haven't used that before, which is also located under create. And this creates a helical shape, whether it's a circle or a square or whatever shape you want. But the default is the triangle, the square, and the circle. So go ahead and choose that tool. And we'll select the plane or planar face to start this coil on. And then the center point of it. And we'll make this the same diameter as the cylinder. Now we can specify whether we want the type to be a height in pitch or revolution in height. We can specify the type of section we want it to be, or how high we want this to cut. There's a circular section, there's a square section, and then an internal, external triangular. So if we do a circular one, for example, this can create some kind of ball thread, especially if you add some fillet like that. But if you want your own custom, shape besides a circle, then there's a little workaround to that. Instead of choosing circular, you would want to choose external. And the section position would be something like on the inside, for example. And the reason why we're using this triangular external section is so we can use the edges of this to create our helical 3D sketch. And that 3D sketch we're going to use to sweep our profile around. And instead of a cut operation, let's create a new body so we can have that body to use the edges as a reference there. So I'll hide body 1 for now. And now let's go ahead and go in here and use the include 3D geometry tool. And it doesn't matter which face we choose here for the 3D geometry because it's 3D and it's not reliant on one plane. So I'll choose that face there. And I'm going to choose this edge and this edge to create 3D geometry about. So now if we hide body 2 and show body 1, we can see that we have this 3D sketch created for our sweep. And our sweep is going to need this path, and it's going to need this guide rail in the middle there. So now we're going to have to create the profile that we want to sweep it about. So I'm going to go here to create sketch, choose a plane to sketch it up, to create that sketch on. I'm going to project by hitting P this point here, so that I have somewhere to start my referencing my sketch on. And then I'm going to draw my own custom shape here. Something like that I can maybe dimension if I wanted to, about the origin. And make sure it's at least past this edge here, or then it won't cut all the way. So I like to drag that out about that far at least. And then we have everything we need for our sweep. So sweep would be located here under create. And we want to choose the path and guide rail sweep. Choose the profile we want to sweep. The path, which is the line connected to the profile, we want to sweep it about. And this is why we highlighted that last one, so we can select it as a guide rail. And now we see a preview of the cut that this sweep is making. And now we have our own custom threading of this using the sweep command. All right. And the pitches and things can be controlled with the coil command here. And you can change the height and the size of it over here. All right. So let's talk about 3D printing these. Let's go ahead and full screen that. So the 3D printers we used, the one we have here is the MakerBot Replicator Plus, as well as the FlashForge Finder. These are standard 3D printers using PLA filament, 1.75 size filament. And one of the tips I want to give you guys for 3D printing are the larger prints are usually more successful because you don't have to deal with the discrepancies that occur when 3D printing. And if you take a look at this picture here, you can see that when I was printing this one, every time it moves up a different layer, you can see on the right-hand side more of this thread. You can see the little divots. And that's really crucial when it comes to printing, especially with smaller threading. But if you have a bigger thread, these little discrepancies won't affect it as much because it's so small within the tolerance. But if it's a small thread like this, then it has a big part to play with it. A way to fix these discrepancies is to, or any 3D printed thread at all, is to clean it up with either a metal nut if it's a bolt like this, or a bolt if it's the female part of it that you need to clean up. So with a metal part, so that it cleans it up. Also, if you remember the orientation in which I brought it into the MakerBot print, vertical is better than horizontal prints. So if you lay your 3D printed thread vertically, like this one closest to the camera here, it's going to give you a better print. But if you lay it horizontally, like the one on the left-hand side here in the back, you can see that there's a lot of discrepancy actually on this thread that occurred when printing this thread. And if you didn't have discrepancies, then you would, or I mean, if you printed with supports, you would still have to break off the supports, and it leaves that kind of finish that you don't really want. So if you can, try to print vertically, but if not, then you're going to have to clean it up later on. Also, try printing the bolts at 100% density. I printed this bolt at 15% density, and you can see it's pretty hollow on the inside. And when you try to when you start to screw it into your component there, sometimes it catches onto something, and then it applies a little bit of torque, or a little bit too much torque that you wanted, and then it snaps. And this has happened a lot of the times when I print threads and I forget to print that at 100% density, it would snap my bolt, and then I would have to it would get stuck in the component, and then you have to get pliers or something to get it out. So print your bolts at 100% density. The ones that I have printed at 100% densities are really strong, and I still haven't twisted them until they broke. So that's pretty good. Also, you guys are wondering about slicer settings. It's different for every printer for sure. Here are the two slicers that we use. There's a FlashForge print, or the FlashForge print and the MakerBot print. These are just the standard settings actually that they were left on. So you can see like the base print speed would be 60 millimeters per second for the FlashForge print. The print speed for the infill is 90 millimeters per second. They're both the default settings. I didn't touch the temperature. I didn't touch the retraction length or anything like that. But if you do want the higher quality thread prints, then I would recommend printing them at a high speed. I know the FlashForge print has a setting where you can change it to that slower print speed setting, maybe 50 millimeters per second, and that eventually gives you that finer thread.
While you're on the slicer settings, Brian, we have a question here from Joseph. Does Autodesk have a slicer, whether in Fusion or something else?
I'm not quite sure. Do you know of one?
Yeah. So you can go into the Fusion 360 App Store, right? So if you go to add-ins, I believe, I don't know if you want to jump in there, Brian, and show them where it's at in Fusion. But if you go inside the App Store, sure. In Fusion, you click on add-ins. I believe it's a drop-down. You should have the ability to go to the Fusion 360 App Store. Just type in slicer, and it'll bring in the slicer in there, right? If you're talking about in terms of let's say a preprocessor that gets your model ready for 3D printing, once you go into make, right, and then you go to 3D print, it's going to ask you a print utility here, right? So again, you do have the option to maybe select some of these. Again, these are completely free to you guys. You just have to download them and then set those settings, right? So instead of using the MakerBot, you would probably use something like, let's say, Print Studio or
Cura is a popular
one.
Yeah, among 3D printers. So yeah, if you guys are printing, I would love to hear about like the settings you guys set. There's also, we can get into a bunch of different topics regarding printing, like if there's webbing or like if there's warping on your printer, I would recommend, laying out a layer of, glue stick. But yeah, there's a whole different topic we can spend hours on. So shoot us an email. Shoot either of us an email or give us a call at our KETIV number there. And we'd love to talk to you guys about that.
So it looks like we have just one question here. So it's from Will. He's asking, so based on all the trial and error that you've done with the 3D printing bolts, is there a method that you prefer over the 3 methods that you went over today?
Oh yeah, definitely the straight out of the box method for method number 1. That gave us a pretty good print, especially using the thread for the cylindrical face for the male component and as well as the female one. Like you saw when I brought in that McMaster-Carr component, it wasn't perfectly the size that I wanted to, or it didn't perfectly line up with the female component, so I had to adjust it by 0.005 of an inch. But other than that, I would definitely recommend the first one. But if you have a custom thread, then yeah, you would go with the coil tool. So, but definitely the first one.
Perfect. Yeah. So Jessica here has a question too. So looks like you came up with 0.005 of a tolerance for your female and your male thread. Would you recommend that to everyone else, or is that just starting point?
Yeah, so for the smaller size ones that you guys saw there, that was about 3/8 of an inch. So that's where I had some trial and error as well. So 0.005 of an inch worked out. I also compared it to the values that the system had. So they had, remember, the 0.004 of an inch and then the 0.11 of an inch. So I took that into consideration as well before I started. I also tried going up to even 0.100 of an inch instead of 0.005 of an inch. The thread still worked, but it was a little looser of a threading. So definitely something to play around with. It's all up to your printer. So if you have a high quality printer, then you can probably print more finer threads.
Yeah, there's a lot of variables, right? So the temperature for which your printer is printing, which material you're printing as well.
Yeah, material as well.
What material were you using, by the way, Brian?
PLA.
PLA. Yeah. Okay. Yeah, so there's a lot of variables. Definitely start off with a baseline. So you can start off with either Brian's numbers, or maybe you've done some 3D printing of your own, right? You have baseline numbers. Definitely feel free to share those with us as well. So with that, it doesn't look like we have any more questions coming in. Again, guys, at the end of the webinar, we are going to have a survey. If you guys do want to see something else, I believe this was a topic that a lot of people had requested to see. So here was Brian showing some tips and tricks, right? So again, feel free to let us know what you want to see next. The next video is going to be on from STL or mesh to actually adding toolpaths to run on your CNC machine, right? So that's something that you guys are interested in. Feel free to tune in to our next webinar. So with that, have a great weekend, guys. We'll see you on the next one.
Yeah, thanks for watching.